When things increase or decrease, and we've talked about this a little bit before, we talked about the formula looking something like this, and then there's that H and K that can be in there, right? This is growth and decay. This is still growth and decay, but this is going to deal with money. That's why I said I used to do.
This is like something that you'd use in real life. Oh my God, 1% of this class is what you're going to use in real life.
Oh. So.
It only takes you 4 months.
Right. Thank you. Are you quite done? Tell me when you're done. All right. So when we talk about growth and decay in the real world context, put your phone up, Grayson. And when you do, shut that door, please. We could do a shoebox project like Calculus did. Did y'all see their projects out there? Huh? They wrote their own word problem and then represented it in a shoebox. And another song.
Anything but that Just Most project. Oh my God.
Some of you really enjoyed it. Yeah, it did take a long time.
Yeah, why did he never put them up?
I'm going to grade y'all's test, I promise. Okay. I just haven't yet. I'm very slack about that kind of stuff. I need to get better.
I'll do it right now.
All right, so we did growth and decay this way. We're going to change the formula up just a bit. It's going to be kind of the same. This is growth. And a couple things about this formula. Your A is still the same, okay? Notice there's a T in here instead of an X. Let me tell you what all of these things mean. A is your starting amount. R is your rate as a decimal. Most of the time they'll tell you that it grows 4%, but you'd have to convert that over to a decimal. What's 4% as a decimal, Grayson? 0.04, right? So remember, if I'm converting over, I move the decimal place over twice. 40 is, yeah, 0.4. That's a percent. Right. I mean, I probably would.
Hold on. Is this what people actually do in real life?
We're fixing to get to the interest part.
Wait, I got a real question.
I'm listening. I can't help but listen.
I actually have a real question, all right? Do I have a bubble butt?
Notice that the decay is the same equation. It's subtraction, okay? So if you decay at a rate of 15%, this would be 1 minus 0.15. What can you think of that decays in value over time?
A car.
That's a 1.
A car.
Like a car, exactly like a car. So for example,
the coffee. I bet you, I can tell I think
for example, I bought a new car in 2008
my parents bought the car in 2005 and it's still running, and I bet you it can sell
for $35,000. The car depreciates in value. I'm just saying. 8% per year. You know, depreciates in value. All right, listen, Grayson. As soon as you, that was only half of them. Oh, that was half of them. So 10:30 or 4:30? There's the 10:30 that was bigger. The biggest one was the morning one.
It was like stacked up.
It's like 71 time and 63 the next. Okay,
You got pretty good money off of it.
just at holidays. It's big at holidays. All right, in 2008, $35,000 depreciates 8% per year. Okay, you know what they say? As soon as you drive a car off the lot, it depreciates in value. No, but they depreciate like that. Okay, so how much is it worth today? Go.
0.8.
Nope. It's just a plug and chug. It's just a plug and chug. Yep. How much is it worth today?
Well, that's not when I was born, so it's 15.
What's the time?
15 years. 15. I was 16. I was born in 2008 and it's 2024. I'm 15.
I think that's right, yes.
Wait, depreciation on
Hold up. I can't.
8% each year. All right, notice what I did. Notice what I did. This is my A, 1 minus R, and then my T.
2024. I'm 15. And my birthday has already happened. I just forgot my age.
I do that all the time. You can put the whole thing in your calculator, but be very careful as you put this in your calculator, because in just a minute, we're going to make it even a little more complicated with the interest. And so you got to watch these parentheses as you put it in there, okay? But basic growth and decay are very, very easy. I'm not going to spend any longer on that unless y'all need it. Okay, let's do interest because that's the good stuff. More specifically, compounded interest, okay? Now, yes, but we're going to talk about what we call compounded interest, which means, Grayson, if you got, what bank do you go to? First Palmetto. If you go to First Palmetto and you take $500 in there and you deposit that into a savings account and it earns interest, the next time, let's say you get $5 interest on $500. You're never going to get that much the first year, but let's just say you do. So let's say you got $505. The next time they calculate interest, do you get interest on your $500 or do you get interest on the $505 that's in there? The 505. So they're paying you interest on the interest they gave you, right? Do you agree with that? Interest on interest? That's what we call compounded interest. When you make interest on interest, because it doesn't take just the $500 that you put in there. It takes the total that's in there. So that's compounded interest. Okay. No, I don't really know what you're talking about. Now, no, if it is, I don't know. Oh my gosh. I don't think so. Now, the amount of money that you get, the amount of interest that you make, depends on how many times they compound it per year. Do they compound it once a year, annually? Do they do it semi-annually, twice a year? Do they do it monthly, which would be how many times a year? 12. Do they do it quarterly? Quarterly? Which would be what? 12. How many times a year is quarterly? 4. Quarterly? 4? How about daily? 365. You see, the more often they compound it, the more money you're getting, right, Will? So here's this little formula we use for compounded interest. We start with, and we'll stick with the A. The initial amount that you put in, so that would be the $500 Grayson walked in with, right? You multiply it by 1 plus, this time instead of just R, you do R divided by, and I'm introducing a new variable here. That variable is N, okay? When you raise it, it's N times T. This is why I told you have to be careful about putting this in your calculator. The new variable here, my N, is how many times per year it's compounded. Now, as we get closer and closer to that number, that N gets bigger and bigger, the more times we compound it per year. We could do it daily. We could do it hourly. We could do it by the minute, by the second. The closer that number gets to infinity, the closer we approach what we call compounded continuously. Thank you, Grayson. I can't even think continuously. And for that, we use another equation, which we call PERT. PERT. This is probably the most common, is the PERT one. PERT. PERT. Now, past this, they are just plug and chug, okay? So let's do an example.
Hey, recording, Mr. G has her name. Edit out that.
Done.
Yeah.
Grayson Dill buys a boat. He buys a boat for $25,000. He purchased this boat, but he doesn't have $25,000. He's just a kid after all. So he went up to First Palmetto and he said, who knows somebody that works there? You go to Safe? Okay, you go to Safe. And you walk in Safe and you say, I need a loan for a boat. It's a good boat. It's worth like $50,000. I'm getting a deal on this $25,000. Give me a loan, give me a loan, give me a loan. They say, okay. They said, we'll give you a loan, but we'll stretch it over 6 years. And we're going to give you an interest rate of 4.5% compounded monthly. At the end of your 6 years, how much have you paid for this boat? Huh? So you don't think that they're charging you interest? Yes. No, you didn't pay. That's how much the boat was. You're taking a loan for, oh my gosh, it's hypothetical. If it's compounded monthly, what is my N? 12. Remember that equation, that formula? It's A1 plus R over N raised to the N times T. Your N, if it's monthly, is 12. Daily, 365. Quarterly, annually, 1. What else do we have? Weekly. See, some of us need it.
God, how are we gonna record it?
That's not a nice word. Don't say it.
How are we gonna edit it?
Annually.
Will just said 7. He said weekly. I thought 7 days a week.
That's not a nice word.
What's that?
What else could it be? What else could it be? Semi-annually. 2. I'm trying to think of any words you might encounter. What is it, Grayson? You still have to use N unless it would literally say compounded continuously. All right, as you copy that, tell me what. Shut up.
All I'll worry about is football. Who's gonna care about the who guys are gonna care? Who some guys are gonna care about this class after we finish it? Not me.
Make sure you can get this number on your calculator. If you can't, the order of operations that you're putting in is incorrect, okay? All right, when you put this in your when you put this in your calculator, this needs to be in parentheses, and this needs to be in parentheses. Otherwise, your order of operations is going to take over. You're going to get the wrong answer. Oh! Sorry. So how much money did the bank make over the... Hence why it's better just to pay in cash when you start. That's for cars too. That's exactly right. Do your parents make a car payment every month? If they do, think about this. Did y'all not know this? This was a good lesson to do then. You didn't realize how much interest was?
No, I'm gonna get to take the bank back home unless you.
Oh, no. That's why you shop around for the best interest rate too. Okay, we might do my real life project. I might fix that up tonight and have y'all do it and start it tomorrow. It's the exponential growth of my real life where we go through and we pick a house that you want to buy. We calculate the interest you pay on it. You pick a job. You find the amount of money that you make in that job. It's kind of like this. It's, yeah.
What was that money thing we had to do last year? We had to go and like everyone went broke. I hated that. I was so broke.
All right, let's try one more, see what happens. It's the Battle of the Graysons.
You're saying if you make a car payment every month, you have to pay more money?
Say it again.
You're saying if you make a car payment every month, you pay more money than you're paying cash?
Absolutely, a lot more. Same with a mortgage payment. Yeah, because you don't have that much money. Okay. Grayson Deal, give me an amount of money that you might go deposit at the bank. Okay, let's say. Okay.
Wait, Miss Me, so like Big Daddy is with actual money?
Who?
My Big Daddy, my grandpa.
Maybe, I don't know.
Yeah.
Older people can do that a long time. Okay. Yeah.
And then his other two cars, they pay all.
I was gonna say our new cars we drive, we pay them off quickly, but we pay them. But like the other vehicles we have, we just pay Okay. You go to the bank with $242,000. I don't know who has that much money. Let's make this a little easier to work with. We're going to say 242.
Daniel Jones is making $355,000.
And Dill walks into safe and they say, we will pay you 2.5% interest compounded daily. And First Palmetto tells Rent, we will pay you 2.3%, but we will compound it continuously. Now it is. See shop around. What? Yes, there is. E is the E that we learned before we left. Just the button on your calculator. It's the button on your calculator. All right. Now, the Battle of the Graysons. Y'all are in 10th grade. Yeah. Y'all are in 10th grade. You are not going to touch this money until you graduate college. So let's say do not do that again. 4 years plus the other 2 years you go to high school. So let's say 6 years. Who has the most money after 6 years? Huh? Dollars. Who has more money after 6 years? No, just $242. It's a little easier to work with. Different formulas. The E on your calculator.
Is it behind the division?
Is the R what now?
1 plus with just the decimal.
In continuous, it's just the decimal. Just the decimal.
Where is he? Yeah, what the heck? I got $242.
How much you start with? What you put in? Use the one beside LN or above LN. Oh, the safe side. This is the safe side. That's the button on your calculator beside the LN, above the LN. So second LN, right beside the 4. Who got the better deal?
I got 135.
Dill got the better deal.
I didn't know that.
How much did you make? Yeah. So just for his money sitting there, he made $39.81. Took 6 years to do it. Change it and see what it would do. Do the same thing.
Being an adult is so
$281,162. All right.